Today we're starting 2.3, solving quadratic equations by graphing and factoring. First thing we're going to look at is graphing them, then we're going to look by solving by roots. We're going to talk about zeros of a function, roots of an equation, and a binomial. If you kick a soccer ball in the air, eventually it's going to hit the ground. The height in feet, which we call h, of the ball after t seconds can be modeled by h of t equals negative 16t squared plus 32t. In this situation, the value of the function represents the height of the soccer ball. When the ball hits the ground, the value of the function is 0. First thing we're going to talk about now is zeros of a function. The zeros of a function are the x-coordinates of the function. It's also called the roots. When we talked in Algebra 1, linear functions had only one root, only one x-intercept. When we're talking about quadratics, quadratics can have up to 2 roots. The first way to find zeros, I have x squared minus 6x plus 8 using a graph and a table. Using this first method. Looking at it, we know because a is greater than 0, that it has to open upwards. We know that the y-intercept is 8 because c is 8. To find the vertex, we learned previously to find the vertex, x is negative b over 2a. That tells you your AOS. So I have negative 6 over 2 times 1. Negative 6 is positive 6. 6 divided by 2 is 3. So I know that the AOS is 3. To find the full vertex, I put 3 into here. What's 3 squared? 9. What's negative 6 times 3? Negative 18. Let's see, 9 and 18 is? 9 plus 18 is? 17. 17 and negative 18 is negative 1. So the vertex is 3, negative 1. So now that we have all those points, we know that the y-intercept was 8. We said that the vertex was 3, negative 1. From this, we could take and draw the u that goes through there. I know because the vertex is symmetrical, the same u has to come through the other side. So 1, 2, 3 gets me back to here. 1, 2, 3, that would have to be symmetrical. It's not perfect, but that's what your graph would look like. If you want to have a better idea of how to do the points, since I knew the vertex is 3, 1, I could have picked points over below it or points above it and found more points, but you only need 3. Questions? Give this one a try. First thing we need to look at, what's your y-intercept? 3. How do you know that? It's your c value. Now we need to find our vertex. To find your vertex, the first thing you need to find your AOS. AOS is negative b over 2a. Negative, what's your b? Negative 2 times 2 times, what's your a? Negative 1. Negative 2 is positive 2. 2 times negative 1's negative 2. 2 divided by negative 2, negative 1. So right now I know my vertex is negative 1 comma something. To find out what that something is, substitute back in the negative 1 in. So what's negative 1 squared? 1, so I make it negative 1. What's negative 2 times negative 1? Positive 2 plus 3. What's 2 and 3? What's 5 and negative 1? 4. Bless you. So your vertex is negative 1, 4. If I graph this now, I know that my y-intercept, 1, 2, 3. My vertex is negative 1, 4. How is my u going to look? Why is it going to look down? Because this a is negative, so I know it went down. This is symmetrical through this line. So if I'm 1 away here, it needs to be 1 away there. And then there you go. You can always take and look at your calculator. Negative x squared minus 2x plus 3. Does my graph look like the graph on the calculator? Close enough. That's just one way to do it. Doing it by graphing by hand. Another way to do it is by finding the zeros. We've been finding zeros for the past week. We just haven't called them the zeros. If we have f of x equals x squared minus or plus 2x minus 3, what we can do is we can factor this and find the zeros. Another word for zeros are roots. Zeros and roots mean the exact same thing. When we did factoring, we didn't look at this f of x thing. I just told you factor it, right? Factor it. Is it special? Why isn't it special? Can't take square root of a 12. So what do you want to try to do first? X and x. What else do I know? Why are the signs different? This one's negative, so the signs have to be different. How do you get a 12? 1, 12, 2, 6, 3, 4. I need to subtract one of these sets and get a 4. 6 and 2. The 6 has to be negative. The 2 has to be the positive. The bigger number always takes the sign of the middle one. Now this is where we left it off last week, right? Now we're going to find the zeros. What you're doing is you're putting in what will make this 0. What number multiplied by anything will get you 0? 0. So one of these two numbers have to be 0. What number can I put into here to make it a 0? Negative 2. If I made this x a negative 2, what's negative 2 plus 2? What's negative 2 times, or negative 2 and negative 6? Negative 8. What's 0 times negative 8? 0. So this is called a 0. X equals negative 2. That's for that one. But I could have also had this one over here equal to 0. What number there for x will get me 0? 6. So put a 6 there, 6 there. What's 6 plus 2? 8. 6 minus 6? 8 times 0 is Both of those are my zeros. Both of those are my roots. Those are your answers.
Where did you get A from?
6 plus 2.
Oh, plus.
What you're really doing, let me erase. You're taking this piece right here and going x plus 2 equals 0. Then you're taking this piece right here and going x minus 6 equals 0. You're setting them both equal to 0, and you're solving. You should be able to look at these and tell me that the answer is this. You'll be able to catch on to that later. Now, graphing it, I have a 0 at negative 2. I have a 0 at 6. So I have these 2 points, my 2 zeros. Is my parabola going to go up or down? How do I know it goes up? X squared is positive. What I need to know is the vertex now. Now, what's in between a negative 2 and a 6? How many spaces are in between here? There's 2 here, there's 6 here, 2 and 6 is, half of that is, so 1, 2, 3, 4. The vertex has to happen at 2. It's 4 in between. I'm going to put 2 into this problem. What's 2 squared? What's negative 4 times 2? And then minus 12. What's a negative 8 and a negative 12? Negative 8 and a negative 12 is a negative 20. Negative 20, positive 4, negative 16. So it's actually way off my graph down here. If I looked in the calculator to check, what was it, x squared minus 4x? Minus 4x minus 12. Oops. Graph. There's the negative 2. There's the 6. This one down here is the 16. Second trace. That's a minimum value, right? So if I did minimum, left bound, I'll just use 0. Right bound has to be over here. I'll use 9. My guess, I don't really care about. My minimum's at 2, negative 16. Ways to check your work. Find the zeros for this one. Not graph, just find the zeros. What's the first thing you should probably try to look at? Okay, it's before is it special? What should I look at? Is there anything in common? What do they have in common? They have a 3, and they also have an x. If I factor out a 3 and an x, what am I left with here? 1x. What do I get here? 6. Now I need to find my zeros. A lot of people forget about this. 3x equals 0. What value there makes it 0? 0. Well, if I divide by 3, 0 divided by 3 is 0. My first 0 is 0. The second one, looking at this one, what value there? Negative 6. Anyone see a shortcut? No? Just what? Change the sign. All right, do this one. X squared minus 5x minus 6. When I try to factor this one, x, sign same or different? Different. Plus, minus. They're different because of that negative sign tells you they have to be different. Okay, 6 is 1, 6, 2, 3. What do I have to do with those numbers? Subtract them. So I need to subtract them and get a 5. The 1 and the 6, when I subtract, get me a 5. So the 6 has to be the negative, the 1 has to be the positive. 2 and 3 does not work because they have to subtract and get 6. If this was a plus here, then you could add to get it. Now, what are my zeros? Negative 1 and 6. Someone said the shortcut is take the opposite. If you have x plus 1, what was your answer? Negative 1. If it's x plus 6, it's going to be 6. When it's just x plus, x minus, it's the opposite sign. We understand this? The only thing different from the last lesson. We did this here, the factoring. Now I'm having you do this. Find the zeros. That's it. Which all that means is if we graphed, you have a point here at negative 1. You have a point here at 6. Now you can use the vertex to find the third point. But is my graph going to go upward or downward? Why upward? That's positive, so I know it has to go like that somehow. I don't know how far down or how far up, but I know it has to be an upward parabola. Where you see a lot of quadratics and where they're used. If any object is thrown in the air, baseball, basketball, football, it's called a projectile. The general function that approximates the height, h, in feet of a projectile on Earth in t seconds is given as h of t equals negative 16 t squared plus v sub 0 times t plus h sub 0. I know this looks confusing. This first part, if I throw something in the air, what is affecting it? Gravity. That negative 16t squared is gravity. That v sub 0, only thing that is telling you is that's your initial velocity. How fast did you start throwing it? In baseball, if the pitcher is throwing the ball at 90 some miles per hour, that's the initial velocity. What happens after the ball's traveled for a while? It slows down because the gravity is pushing down on it. But what matters is how fast was it initially thrown. Also what matters is the initial height. If I had you throw a football from the front of the building and see how far you can go, and then I'm going to go up on top of the building and throw a football, which one's going to go farther? Why will mine go farther? I'm up higher. It adds the height, which gives it more distance before it hits the ground. These are little things you have to know. If you watch baseball, and they say that home run was 426 feet, did someone go out there and actually measure how far that went? No. What they did is they looked at, okay, how fast was the ball going? What was the bat speed? What angle did they hit it from? From those things, knowing gravity and how tall the person is, they can estimate where it's exactly going to fall. All right, a golf ball is hit from ground level with an initial velocity of 80 feet per second. How many seconds later would the ball hit the ground? All right, if you don't know golf, little white ball on the ground, you hit it with a stick, goes up, it comes down, right? You use the same formula. H of t equals negative 16 t squared plus v sub 0 t plus h sub 0. Gravity does not change regardless of the problem. As long as we're talking about Earth, we're going to stick with this gravity. Negative 16 t squared plus, what's your initial velocity? 80. So 80 t. That v sub 0, that little 0 does not mean anything. It is just a label. Bless you. H0, what's the initial height of the ball?
80 feet.
Where does the ball start at? What's the ground? 0. And that's the thing. The problem never says 0. It just says the ball starts at ground level. You have to think, and when a quarterback throws a pass, Is the ball at ground level? No. It's at his reaching point, right? So that's where it would be calculated of how far it could go. So what I want to do is find out when's the 0. Now this right here I'm just going to scribble out because we don't need that there, right? You have negative 16t squared plus 80t. We're going to look at what do they have in common. They both have a t. So they have a t. Anything else? 16 does go in 80. So I'm going to take out a negative 16 just to make it a little bit easier on ourselves. If I factor out a negative 16t, what's negative 16t squared divided by negative 16t? Just 1t. What's 80t divided by negative 16t? Negative 5. Now what I want to do is find our zeros. What value for t will make this 0? 0. What value for t will make this 0? 5. What this is saying, the ball will be on the ground at 0 seconds and at 5 seconds. Now, just showing you in the calculator. Negative 16 t squared what was it, plus 80, and then nothing else. Graph. Yeah, we're not going to see everything because it goes up real high. The ball goes up, the ball comes down. 1, 2, 3, 4, 5. I can also look in the table. Second graph. At 5, the ball hits 0 again. So it takes 5 seconds for a golf ball to go up and come back down. That's without any wind coming into play. A football is kicked with a vertical velocity of 48 feet per second. How long is the ball in the air? So just like before, we have our 0 equals negative 16t squared. You told me it's plus 48t, and it's kicked off the ground, so there is no 0. What do they both have in common? They both have another 16t. This one's going to be t minus 3. Of course, when the ball hasn't been kicked, what's the height? 0. How many seconds before the ball comes down? 3 seconds. So the ball will be in the air for 3 seconds. Now, what I just heard someone say it's negative 3. It's always the opposite of this. But what would happen if one of your answers were negative 3? What would that tell you if you had a time of 5 and negative 3? What's not possible? You can't have a negative 3 in time. That negative 3 doesn't work. The only number would be the 5. It happens when it doesn't start at 0. That's when you start getting the different numbers.